In this video, you will be creating your own decentralized lottery smart contract. Now, we will be using Solidity to write our smart contract, and we will be using the Remix IDE to go ahead and test our smart contract. Okay, now this is part 2 of our video series on how to create a decentralized lottery contract. So for part 1, in which I give a general overview of all the aspects of our project, go ahead and hit this link. Now, without further ado, let's hop right into it. Real quick, I just want to give a shout out to Block Explorer. I did get stuck on a particular part within my smart contract. Now, originally when I did this project, I was using an older version of Solidity, whereas now I upgraded to the 0.8.13 version. So there were a few things that I did have to change. However, looking at his code on YouTube definitely steered me in the right direction as to, how I needed to fix. It was like one or two little errors with my KECAC 256 hash algorithm. He definitely helped me out in giving me some guidance on fixing this error. So go ahead and hit him with a follow, Block Explorer on YouTube. All right, guys. So if you like this type of content, go ahead and hit that like button as well as that subscribe button. Hit that notification bell for all my video notifications when they come out. All right. And go ahead and hit that comment section. If you have already done a project like this decentralized lottery system, or if you have any comments on the code that we are creating currently, go ahead and leave that in the comment section below, as well as come up with any ideas for any type of projects that you would like for me to go over, or any topics that have to do with Solidity, and I will go ahead and try to make videos on them. All right. But like I said, if you like this content, go ahead and hit that like button and hit that subscribe button. All right. So let's jump into it. All right, guys. So jumping right into Remix, I am creating a new file, and the version of Solidity in which I'm going to be running is going to be the most up-to-date version, which is 0.8.13. Now, we are going to be deploying our smart contract to the test network using other frameworks. However, for testing purposes right now, let's go ahead and create our smart contract within the Remix platform. So I'm going to start off by creating a file called lottery.sol. Now, don't forget the order of declarations for our variables, guys. So we want to specify the type of visibility as well as the variable name when declaring variables. So I'm going to specify address. I'm going to declare it public. And I'm going to be creating my first variable, which is my admin variable. Next, I'm going to be creating an array, and I will be making it public for my contestants for the lottery. Now, guys, if you are unfamiliar with the different type of data types within Solidity, go ahead and click this link, and it's going to take you to a video in which I explain the different data types as well as how to declare them within Solidity. All right. So from here, I'm going to go ahead and make another variable called unsigned integer, or should I say it's called ID, but it will be an unsigned integer, and I'm declaring it public. Now, this variable is going to identify the particular lottery that we are playing. So remember in the first video where I gave a general overview of our project, remember that I said we will create a function that will allow us to completely delete the contestants within our lottery and basically start from new. And so we do want to record the different winners for the different lotteries that are being played. So for instance, if I play a lottery right now and then I wipe the slate clean and then I bring in more contestants and I play another lottery and I do that, let's say 5 times, this variable ID will identify the different lotteries that were being played. And lastly, I'm going to be declaring a mapping. Now, once again, guys, if you do not know what a mapping is, go ahead and click this link, and it's going to take you to a video in which I go more in depth on what a mapping is. Okay. So this mapping is going to store addresses, and they're going to be payable addresses. And I'm going to declare this mapping public, and I will be calling this mapping history. Now, this mapping is going to be recording the addresses of the different winners of the different lotteries that we will be playing. So let's go ahead and declare our first function. Now, our first function is going to be a constructor function. Remember, constructor functions are important in JavaScript as well as in Solidity. And if you don't know what a constructor function is, once again, hit this link where I go over what constructor functions are and why they are necessary. All right, so for now, just going to be creating this constructor function. And I am going to be setting my admin, which is the deployer of our function, is going to be equal to message.sender. All right. Now, message.sender is a global variable. And if you aren't familiar with global variables, hit this link where I go over exactly what global variables are and why they are important within Solidity and when we get to use them as well. All right. So next up, I'm going to be declaring that my first lottery game that is being played is denoted as ID equal to 1. All right. So the winner of the first lottery game that you play is going to be associated with ID number 1. The winner of the second lottery game that you play is going to be associated with ID number 2. Now, you may be wondering how we're going to automatically find out the address of the person who is creating the instance of our contract. So in order to describe that in a better fashion, let's go ahead and jump into this diagram that I created. All right, so you have the account of the user that is deploying the contract. This user initiates a transaction, okay? Once this transaction is initiated into the Rinkeby test network, a contract instance is then created. All right, so from the account to the transaction, message.object is what's describing this, okay? So when we go back to Remix and you look at the global variable that we use, message.sender, this object has some properties on it that describe both who sent the transaction to the network as well as what that transaction consists of. Okay. All right. So remember that global variables just means that we don't have to do any declaration for these variables. All right. They're always going to be available either within a function or without a function. Whenever we're using the global variable message dot whatever, it works for both the transaction as well as a function being called. All right. All right. So back over here in our code, it's important to make sure that anytime that a new instance of our contract is being initialized, that the address of the person doing the initializing is associated with our administrative variable or admin. All right, so moving on to the next function, I'm going to create a getBalance function. Okay, now this function is going to allow me to check the balance of our lottery pool at any given moment, and anybody could call this function. Okay, so it's going to return an address this dot balance. So next, let's go ahead and create our enter function. Now our enter function is going to allow users to go ahead and initiate a transaction or a donation into our smart contract for whatever amount of ETH that they set forth. Okay, so I'm going to, actually I did this wrong. I'm going to make this public, obviously, because I want anybody to have access to this. And I'm also going to make it payable because remember, in Solidity, in order for you to send funds to an address, that function must be payable and that address must be declared payable as well. All right. Now I'm going to require that for the user to donate to our smart contract, that their donation must exceed a certain amount of ether. Okay. Now you can put whatever you want for this amount of ether. Just keep in mind that we are using the Rinkeby test network, meaning that you're going to be using test ETH, and there's only a very limited amount of ways that we can obtain ETH or test ETH currently right now for the Rinkeby test network. Okay, so definitely want to keep this low. All right, so for me, I'm gonna put it at, say, I don't know, 0.05 ETH. Now you can declare ether straight up like this on Solidity. If you don't put ether, for instance, like how I have it here, it will, or Solidity will actually think that you are talking about Wei. All right. So if you want to specify a specific amount of ether within Solidity, you have to go ahead and write ether as you see it here. All right. So next up, I'm going to push the address of the person that is donating this ether into my contestants array. Okay, so push in Solidity is used just as push is used in JavaScript for those of you that have experience with JavaScript. So you have your contestants array, and as more people donate into our smart contract, their address will go ahead and be pushed into our contestants array. All right, so next up, let's go ahead and create our random number function. Now remember guys, the purpose of this function is to generate a random, or in our case, a pseudo random number, so that we can essentially attribute that number to our contestants. All right, and this will allow us to pseudo randomly select a winner. Now I know I didn't speak about this earlier with the previous functions that we just made, but if you see me declaring the different common function types, public, view, constant, pure, payable, you know, if these declarations are new to you or if you don't understand the meanings behind them, go ahead and click this link where I go over the different common function types that are supported by Solidity. So I'm going to declare this random function public view, and it is going to return an unsigned integer. Now this integer is going to be a large integer because we want it to be completely random, or in our case, once again, semi-random. I know I keep saying completely random, but that's not the technical term. Now, to better understand how our pseudo-random number is going to be generated, let's flip over to this diagram. So our random number generator is going to consist of these components. So as you can see, the three different inputs for our pseudo-random generator algorithm is going to be current block difficulty, which is essentially just the time it takes to solve a particular block currently at this point in time. Now, the second parameter is going to be the current time. And the third parameter is going to be the address of the contestants within our list. All right, so you grab these three numbers and you input them into our hashing algorithm. Now, getContestants can also be seen in Solidity as the SHA-3 algorithm. Essentially, getContestants is a class of algorithm. SHA-3 is just a particular instance of it. So you will probably see getContestants more within Solidity, but just don't be surprised if you see SHA-3. All right, so this is the algorithm that our parameters are going to be put into, and it's going to spit out a very large number. And this large number is what we're going to associate with the particular contestants within our list. All right, and that's how we're going to generate our pseudo random number. All right, so I hope that that's clear. And I'm going to go ahead and jump back into Remix. And from here, let's go ahead and call the getContestants algorithm. Now I'm gonna, for the block difficulty, I'm literally gonna write block.difficulty, which grabs the current difficulty at this particular time to solve a block. Then I'm gonna separate it with a comma, and I'm gonna put the current time, which would just be block.timestamp. And lastly, I'm gonna put the address of our contestants, which is going to be just contestants. All right, we're gonna finish this line off with a semicolon. And I see that I have an error. Oh, I accidentally put views instead of view. And I accidentally put integer instead of an unsigned integer. So I see that I forgot something here, which is why it's giving me an error. And I'm going to go ahead and write abi.encode packed. Now, once again, for more information on ABI and bytecode, go ahead and hit this link and it will take you to a video in which I go more in depth as to what ABI encode packed as well as ABI encode is. But in a nutshell, the difference between ABI.encode as well as ABI.encode packed, which is what we're using here, is that ABI.encode is used for basically when you're dealing with more than one dynamic type, whereas ABI.encode packed is used for all types of data and basically any type of input. All right, once again, if that seems a little confusing to you, go ahead and hit this link and it'll take you straight to it. All right, so I'm going to go ahead and create my next function, which is going to be my pickWinner function. All right, and so there are going to be no parameters for this function. However, I am going to declare it public. All right, so you may be wondering, how exactly are we creating a random large number that has been generated and basically associating it with the address of our contestants within our list? Well, in order to better understand that, let's go ahead and jump into this diagram. All right, so I want you to focus on the middle boxes. All right, so this is the process that we're going to be implementing into our smart contract. All right, so we're going to grab our random function, which we just created. All right, and we will be using the modulo operator to divide it by our contestants dot length. All right, so this is just the amount of contestants that we have. And from there, we will then generate a random number between 0 and the amount of contestants that we have. All right, so the winner will be the person at the index in the contestants array. All right, so modular operators are the same in Solidity as in JavaScript. So if you're familiar with them in JavaScript, they are no different than modular operators within Solidity. All right, so basically it just returns the remainder between two different numbers. So let's go ahead and give an example really quickly. So let's say I want to do 10 modular 3. Notice how it's 1 because 10 is divided into 3 parts 3 times, which is 9, and there's just a remainder of 1. Another example, if you have 10 modular 4, you're going to get 2. All right, so 4 goes into 10 2 different times, but there's a 2 remainder. So that's how we're going to use our random number generator. All right, so let's go ahead and hop back into Remix, and I'm going to create an unsigned integer index. And just like the diagram that I just showed you, it's going to be random, which is our random function. We're going to call our modular operator, and I'm going to use contestants.length. All right, so now that we have an index of the contestants, we can go ahead and select a winner. But from here, I want to go ahead and send the funds of our lottery smart contract that we've accumulated, and I want to go ahead and automatically send them to this address. So how exactly am I going to do that? So I'm going to go ahead and call my contestants index, which I just created above, and I'm going to use a transfer function. And from here, we're going to go ahead and type in address this dot balance and end it with a semicolon. All right, so this is basically just a reference to the instance of our current balance. And so if we want to go ahead and send this to the address that was selected as the winner of our lottery system. Also within this function, I want to go ahead and record the address of our winner into our history mapping. You remember our mapping up here that records all of our winners so that we can go back and depending on which ID we would like to use, whether it be 1, 2, 3, the different rounds of the lottery, we could go back and check who has won which lottery. I'm going to go ahead and equate my array of historical winners to my contestants index. All right, and that's going to be increasing in increments of 1 because there's only going to be 1 winner per round. And lastly, I'm going to go ahead and reset the whole contract within this function. So this function is very important. It's basically the meat and bones of this contract. So I'm going to say new address is payable, and it's going to be an array starting from 0. All right, so one of the last things that I want to implement within our smart contract is I want to have the ability to look at a list of our contestants. All right, up until this point, we have created a mapping, we have created arrays, but there is no actual function that is allowing us to go ahead and draw up a list of all of these contestants. All right, so in order to do so, I'm going to create a function called getContestants. This function is going to have no parameters. I do want to make this public, All right, because I do not really want to withhold that information from anybody. You know, that's not private information, and the whole point of this smart contract is to make it as decentralized as possible. Of course, nothing is fully decentralized. You know, we are the administrators of this contract, but we're going to make it as decentralized as humanly possible. All right, so this function is going to return an address, and or should I say is going to return addresses, and these addresses are going to be payable, and they're going to be stored to memory. All right, now if you don't know what memory is, storage, call data, saving data types to the stack, go ahead and hit this link and it'll show you the 4 different data locations that are supported by Solidity. All right, so hit that link if you are not familiar with how to save data locations and what data types go in data locations. All right, to maximize, or should I say minimize, the amount of gas that we should be using when deploying our smart contracts. All right, so I'm going to go ahead and return contestants. All right, and this is the absolute last thing as far as Solidity is concerned. We're going to go ahead and identify a problem. Now, I don't know if you've noticed this, but our pickWinner function is public. And so essentially when we deploy the smart contract, anybody is going to be able to go ahead and call the pickWinner function. Okay, so remember that our pseudo random generator generates a random number, so nobody can really dictate, you know, who the winner is going to be. But as far as calling the pickWinner function and closing off the list of contestants, at this point in time, if we deploy this contract, it will be completely public and anybody will be able to call this pickWinner function. All right. So what I want to do is I want to create a function modifier. Now, if you don't know what function modifiers are, I want you to go ahead and hit this link. Seriously, stop what you're doing. Stop this smart contract that you're currently writing. Hit this link if you don't know what function modifiers are, because they are extremely important. All right. So if you have already watched that video, we're going to go ahead and implement a function modifier in this smart contract. And we're going to implement it for our pickWinner function. All right. So how I'm going to do that is I'm going to call modifier and I'm going to call it restricted, because I want this modifier to restrict the function in which I am calling this modifier. All right. So this modifier can be called for any function, not just the pickWinner function. So I'm going to require that message.sender be equal to the administrator. All right. And I'm going to go ahead and close this modifier with a underscore as well as a semicolon. So what this does is that it allows me to modify any function with this particular line of logic that I just created. And all I have to do is call whatever I named this modifier, which in this case is restricted. All I have to do is call it within the parameters of my function. All right. So if I go here for pickWinner, I'm going to go ahead and call restricted. It's looking like I forgot a semicolon here. All right. And bada boom, bada bang, we have our smart contract. All right. So let's go ahead and deploy this smart contract. Compile. Now, notice my address. All right. So my address, the administrator address, is going to be 0x5b3. All right. So I'm going to go ahead and click deploy. Looks like everything went smoothly. All right. So I have my different functions here. All right. So first things first, let's see who my administrator is. And that should be me. 0x5b38. This should never change. All right. I should always be the administrator because I'm the one that deployed this contract. Okay. Now let's go ahead and get the balance of our lottery pool. So as you can well imagine, nobody has donated to this pool, so it should be 0. And it is. All right. So let's go ahead and get a list of contestants, even though nobody has signed up for our lottery system. As you can see, it's showing an empty array there. Let me go ahead and extend this up a little bit. All right. Let's just for, educational purposes, look at our random number generator. Now, as you can see, every time that I call this function, it's constantly giving me a very large number, and it is random. So there is our random number generator. All right, so let's go ahead and donate some ETH to our lottery pool, and let's get some contestants in. All right, so I'm gonna go ahead and switch to my next address, which is 0xAB8. All right, so from here, I'm gonna go ahead and switch this to ETH. And I'm gonna donate, say, let's donate 3 ETH. And remember, in order to donate, you have to click enter. So I entered there. I'm gonna donate 4 ETH with this next address, 0x4b2. Enter. And then I'm gonna donate 5 ETH with this next address, 0x787. All right, so it's looking like we have 3 contestants within our contestants list already. All right, so let's go ahead and switch on over. Actually, let's stay at this address really quickly. As you can see, the admin is still my original address, the person who deployed this, so that's never going to change. One thing that I want you to notice really quickly before I switch to my admin address, if I call the pickWinner function, what address is it going to show me? I want you guys to think about it real quick, all right? So if I am on, this is the deployer's address. If I am on one of the contestants' address, let's say I switch to this contestant, all right? If I call the pickWinner function, what's going to happen? You're going to get an error, all right? Let's say I switch over to this one. You're going to get an error, okay? And going back to our code, this is why we use this function modifier of restricted. Okay, because if we take out restricted, where's it at? Right here. If we take out restricted, anybody can call this pickWinner function. All right. So I'm going to go ahead and go back to my administrator address account. And so as you can see, I want to look at my balance for the pool, for the lottery pool. Now, anybody could call this. You don't have to be an administrator. And if I donated 3 ETH for the first address, 4 ETH for the second, 5 ETH for the third, 3 plus 4 is 7, plus 5, you're looking at 12 ETH. So we should have a total of 12 ETH within our pool. All right. And there you go. Now, for those of you that don't know, this is actually giving us a number in way. And there should be, if I'm not mistaken, there should be 18 zeros after the 12. Okay, so 18 or 19, one of those two. So, but this essentially means that we have 12 ETH, but they're just expressing the units in way. All right, so it's looking like that function works good. Let's look at a list of our contestants. All right, and boom, as you can see, the first contestant is 0xAB8. The second contestant is going to be 0x4b2099. And then the third contestant is going to be 0x787. All right, and it's looking like that is working properly. Let's say I want to get the address of my first contestant. Remember, this is an array, so you're going to have to put in 0 as your first value for the array. All right, so contestant 0 is going to be the first address that donated to our contestants list. All right, and if you look, you go to contestant 2, which is the second in our array, it's going to be 1. And if you go to 3, which is 2, it's going to be that one. Notice how if we go to contestant number 4, which should be the third slot within our array, you get an error. Okay, so it's looking like that's working fine. So our enter function is working fine. Admin, contestants, getBalance, getContestants. Our history has, well, we haven't used our history or ID yet, but we will as soon as we call the pickWinner function. And we have our random number generator. All right, so I think it's time to go ahead and pick a winner. All right, so let's pick a winner. And we have our winner. So let's go ahead and look at who it is. And our winner is going to be the second contestant. as you can see, the account balance is 12 ETH more than what it previously was. Okay, it was previously at 95.999 if I'm not mistaken. All right, so that is the winner. So if I want to see who won and get a list of who won, I'm gonna go ahead and click ID. And as you can see, well, I guess I should have done this before I clicked the pickWinner, but ID 2. So basically this is saying that this is our second round of the lottery. So if I would have clicked ID before I would have clicked the pickWinner function, it would have said 1, which it was essentially telling us that this is the first round of the lottery. So now this is the second round of the lottery. If I want to look at the winner from the first lottery, as you can see, the winner is 0x4b209, 0x4b209. All right, so there we get a list of all our winners. All right, so there you have it. You have officially created your own decentralized lottery system. Or have you? I mean, let's be honest, this was cool and all, but how are users going to use your dApp? How are users going to log in with their MetaMask account and use their ETH to go ahead and donate to your smart contract? Now, using Remix does have its benefits, but in the real world, Remix is definitely limited as to the things that we can do with our smart contract. That is why we are going to be using Ganache as well as Truffle in order to test our smart contract. And then from there, we're going to go ahead and create a front end for our application so that anybody could use our decentralized lottery system. So I'll catch you in the next video.